Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain about first topic after midterm test for this course. This topic is about curve fitting. So, curve fitting is a method to determine a graph that approximates a given dataset. The graph does not have to exactly pass through the dataset, but it is expected to provide the smallest possible error. This is done in order to know the relationship between the related variable. For example, this graph, we can see that the the expect the approximate graph is not exactly passed through the data set. If we take a look at the last data point, we can see that it's not passed, but for overall of the graph, if we count the error of the data set, we'll give a smallest possible error. Curve fitting is usually carried out on discrete data that may be obtained from the experimental or simulation results. In experimental data, error occur due to the various factors such as measuring instrument inaccuracy, noise, measurement method error, and etc. Okay, now we will introduce three terms. So this three term is intended to find correlation between two variables, dependent and independent variable or free variable. But there is main difference between them. Curve fitting, regression, and interpolation. We will discuss about the difference between them. It seems like they three are similar, but curve fitting is usually found on mathematics term, or we can say that it is a general form of uh, predict graph prediction. In the curve fitting, we can approximate the graph for linear, polynomial, exponential, and even a graph like a circle or hyperbolic, and whatever the graph you can approximate to by curve fitting method. Regression is more specific to statistics, so it has to correlate the variable, the independent and dependent. It has to be it have to correlation between two. And then last one is interpolation. Is a looking for relationship between two variables in finite interval, especially between two data. The relationship is considered linear and must pass through the data point. That's a difference. And now we will discuss about method uh, for solving curve fitting. The most popular method is least square regression. So least square regression is a technique to approximate the dataset with a minimum difference between the data point and graph. Least square regression is applicable for all graphs, including linear, polynomial, exponential, and also multiple linear. But in this section, two methods will be discussed is linear regression and polynomial regression. Okay, first one is linear regression. So the general equation for linear function is actually just y is equal to c1 plus c2 times x. It's a general form of a linear equation. But in this case, we have e, which is it is called error or residual. So a0, a1, and e are all constants. Our objective is to minimize the sum of error actually, but uh, in this course or in this method, linear sorry least square method, we want that the square of the error is minimum. So the SR is equal to sigma E square. So why should we choose E square rather than just E? Because the E value or error is may has a positive or negative sign. Uh, as the figure previous, uh, the expected graph may above or below the particular data. So if we if we sum the total error, it may has a zero value or even negative, and we want that to happen. So uh, we we just subtract y measure minus y model and then square it. The next is we determine a0 and a1. The method is differentiate SR over the each coefficient. So dou SR over dou A0, we differentiate SR over A0. As we know that the SR is constant, so the derivative is 0 in here, right here. Sorry, this one. Okay, and then uh, this equation, okay, we differentiate by a0, then we obtain minus 2 times sigma y1 mean a0 mean sorry negative a1 xi. It's just yeah, differentiate, and then we differentiate the SR by a1. We obtain this statement, and these two are equal to 0. Okay, we obtain this 0 is equal to sigma y1. We distribute the previous statement, and then okay, in this section we multiply the a0 by n. N is equal to the number of data. Why we now realizing that sigma a0 is equal to n times a0, we can express the equation as a set of two simultaneous linear equation with two unknown a0 with two unknown a1 and a0. Then we obtain a1 is equal to this and a0 is equal to this. And in this figure we can see that the, the example of linear regression or linear curve fitting. Next one is polynomial regression. It is actually has the same idea to the linear regression, and I will give an example for 2-degree polynomial. Y is equal to a0 plus a1x times a1 x squared plus e. E is error. Sum of residual is the same. We manipulate e to the left hand side, and then we uh, y on the right hand side. Then we obtain SR. The sigma of the error square is called the square of residual. And after we just like the previous proof, we have three unknown constants, a0, a1, and a2, that we must specify all three constants. The same method, we differentiate the dou SR over dou a0, dou SR over dou a1, dou SR over dou a2, and all three of these is equal to 0. And then we use the same way, we distribute, and then we obtain a simultaneous linear equation, actually, where all the summation are from I is equal to 1 through n. Note that the above three equations are linear and have three unknowns, a0, a1, and a2. The coefficient of the unknowns can be calculated directly from the observed data. For this case, we can see that the problem determining least square second polynomial to solving a system of three simultaneous linear equations. Okay, that's all from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.